Hello, and welcome back to Introduction to Astronomy. My name is Paul Eric, and I'll be your host. This series of videos is a recording of the lectures that I would give to my students who are taking Introduction to Astronomy at OTC in Springfield, Missouri. So this lesson is all about the cycles of the sun and the moon. So if you recall, in the last video, lesson number 2, I was talking about the constellations and how to locate them in the night sky. The positions of those constellations change from day to day, month to month, and season to season. So we want to look at those phenomenon and try to explain it in terms of what is the Earth doing, what is the moon doing, and what are other objects in the solar system doing. So your lesson objectives for this particular lesson are to know what planetary spin is, planetary tilt, eccentricity, orbital speed, and orbital tilt. Be able to explain why does the sun seem to rise in the east. Know what causes the different phases of the moon. Explain what causes solar eclipses, lunar eclipses, the seasons, and retrograde motion. So if you are reading in your textbook The Essential Cosmic Perspective by Bennett, this would still be in chapter number 2. There are some crash course episodes available. So episode 3 entitled Cycles of the Sky, and then moon phases, and then eclipses. So episodes 3, 4, and 5. So let's talk first of all about what can a moon or a planet do. So one of the things that they do is that they spin. So for example, I don't have a model of the Earth, but here's my model of the moon, and you can see that I can spin it. So objects in our solar system are spinning. The Earth is spinning once every 24 hours. The moon is spinning once every 30 days, approximately. So objects spin. Also, they can be tilted. So here we've got the spin axis if it was straight up and down, but most objects, their spin axis is tilted with respect to the plane of the solar system. So if we assume that the plane of the solar system is horizontal, then objects in our solar system are generally tilted. So for example, Earth is tilted, how much? About 23 degrees. But we're going to talk about Uranus, which is tilted like this. So it's actually on its side. And then we're also going to talk about Venus, which is tilted upside down, so that it actually rotates backwards. Now you might be wondering why. So why would the different objects in our solar system have different tilts? And the answer to that is that when we think the solar system formed, it formed from a lot of different collisions. So that originally the objects in the solar system spun straight up and down, but because they bumped into things, they were tilted at various angles. We're also going to find that this would also explain how the Earth got its moon. So we'll talk about that in a future episode. Okay, so that's spin. So objects spin, and then objects also orbit. So I have my handy dandy orbital simulator here, which looks remarkably like a hula hoop. But the idea is that, let's pretend that this is the plane of the solar system, so it's horizontal, and then planets go around the sun in orbits, but just like the spin axis can be tilted, so can the orbital axis. Now for most of the planets in our solar system, it's not much, less than 5 degrees. But you can, if you measure it precisely enough, you can actually tell that sometimes a planet will be up here above the plane of the solar system, and sometimes when it orbits, it will be below the plane of the solar system. That's going to be very, very important when we talk about the moon. So just keep that in your mind, that the orbit of an object, whether it's the moon going around the Earth or whether it's the Earth going around the sun, can be tilted. Okay, another thing that can vary is going to be the eccentricity. And for an ellipse, it's the amount that it's stretched out. So here's a circular orbit. So this would have an eccentricity of 0. And then the more that I stretch it, the greater the eccentricity becomes. And so the eccentricity goes from 0 and approaches 1. And when the eccentricity actually becomes 1, meaning I've stretched this thing out so much, it kind of snaps. And then it turns into a new kind of orbit. And we'll talk about that later in the course. Okay, so let's take a break right here. And then when we come back, we are going to talk about daily phenomenon.